Graphing a polynomial, a rational function, I chose a rational function. Okay, and again, the longer version, I did a lot of explanation, but I'll just say you find the zeros. Zeros of the numerator, you find here. 0 is x equals 3. You don't get any zeros from this term. This term gives you zeros at x equals -3 and -2. Put -3 here, -2 here, and 3 here, the zeros of the numerator. And those zeros are points that the graph of the function has to go through. Then we find the zeros of the denominator. Well, x squared plus 2 can't be 0. X squared is always positive, and when you add 2, it's still positive. X minus 1 is 0. Now that has a multiplicity of 2, but x minus 1 is 0. And so x equals 1 is a 0 of the denominator. It's not a 0 of the numerator, so it's a vertical asymptote. If it's 0 of the numerator, then you got to be a little more careful. I'm not going to talk about that right now, though. Read that and practice it. Okay, so we have a vertical asymptote at 1. Then we figure the signs of these things. From -infinity to -3, we can plug any number less than -3 into this thing, and we would find that this factor is negative, all these other factors are going to be positive if x is less than -3, giving us an ultimate negative, because we've got a negative times 2 positive divided by actually 3 positive, this one, and 2 of them for this one, but you get the idea. Okay, and similarly, we conclude that the signs of these factors between -3 and -2 are negative, positive, negative, positive, positive, in this order, negative, positive, negative, positive, positive. Following the same order, between -2 and 1, the expression has to be negative, because this one's negative and all the others are positive when x equals 0. We could pick any x value between -2 and 1. We pick 0. We find that it works that way. Okay, so between 1 and 3, we could choose x equals 2 and evaluate these things. We would again get negative and then 4 positives. And we're getting all these positives because both the terms in the denominator, both the factors of the denominator are going to be positive. X squared plus 2 is positive, and we square x minus 1, it's going to be positive. Okay, and then for large values of x, we can reason it out that all these are going to be positive, so the graph is going to be positive. We also note that the degree of the numerator is going to be 5, and the degree of the denominator is going to be 4. So that if we were to do a long division of this into this, we would get an x then plus something over the denominator, okay? We'd just get x and then a remainder. Meaning that this thing behaves a lot like y equals x when you get out there or when you get out there. In any case, it's got to go negative here, it's got to go positive here. So, in order to go negative to positive here, goes through here, stays positive, then goes negative again, and then approaches the asymptote in the negative direction. On this side, it comes up from the asymptote in the negative direction because it's negative here, goes through this, becomes positive, and stays that way. So there's our graph.